we entertain everything here. So we'd like this to be an open and honest dialogue. And if you have any questions or comments, like I said, just feel free to throw them out there. And you can go off mute and interrupt me or interrupt Jory during the presentation. You can also use the Q&A, or you can use the chat function to get a hold of us. So we'll keep track of that during the workshop and try to answer all questions as quickly as possible. So getting going with the workshop, we'll just go over a little briefly about Kubernetes, and so in the next 15 or 20 minutes we'll go over just Kubernetes and how it basically works. And so when we think about Kubernetes, we need to really take a step back and think about how applications have been designed up until Kubernetes was introduced. And so looking at the slide here, we have a monolithic application, and this monolithic application has different macro components inside. So it'll have a front end, a back end, it may have database, it may have message transport, it may have all these different components, but they're all bundled together into an application and distributed as a whole. So all of these macro services are all included. And so within a monolithic application, there's usually several modules, and each of these modules perform some action or is some specific task. And so that's where we came from. And so what we're doing with Kubernetes is we're really breaking up those individual tasks that are included in a monolithic application, and we're creating microservices. So each task now has its own container, it's running in its own process. So as we do this, we can decouple these things. And so, if we think about the standard monolithic development cycle, you may have 5, 10, 100 developers working on a project, and everything has to be ready to go before we can release a new update or release a new product. And so, some components may not change at all. If we think about some monolithic components or monolithic products, looking at, I had a friend in the DevOps and in the development world, and he worked for Microsoft for a while, and his job was to maintain the file open button. And every time Microsoft did a change, he had to go in and do QA to make sure that file open would work properly. And so that's kind of what we were seeing before. You had to make sure all the dependencies worked. And so as we move to microservices and each one having its own process, these microservices can be deployed independently of each other and updated independently of each other. So, one of the nice things about it is we can deploy these microservices in public clouds, private clouds, on-premise. We can also break these up and dispatch each of these microservices to different, say, cloud providers, different clouds, cloud instances or cloud regions. And so then we're not reliant on any specific infrastructure to run these microservices. And so when we have microservices, now they need to communicate. And so each microservice will have an API or a service. We'll talk about services in a minute, but typically it's an API call or there's a queue mechanism. And so that's what connects these network of services together. And within a microservices architecture, all of these independent processes that are running, they each access, such a, in the case of where there's a database involved and we're storing data, each of these microservices can own their data and they can independently update the database. So now we don't have a bottleneck, or we don't have, one place where everything could fail or slow down. So just taking a look at it as the overall process, going from a a monolithic application to microservices provides a lot more flexibility for our development teams and our, and as we move our developers and our operations teams closer together through microservices, we can get get operations involved earlier in the process, so we can avoid performance problems. We can avoid service outages and other things that could be related to upgrades or introducing new technology, because we're breaking some of these dependencies. So it's really an exciting world. And so Kubernetes is, let's see. Oh, there we go. Container technology. So this is really the most suitable option to create and distribute microservices across dev environments and clouds. So we'll just talk a little bit about container technology. And like I said, I really don't want to, overload you with a ton of slides. So we'll go through these pretty quickly. But if we think of a container, that is the smallest compute unit within a Kubernetes cluster. And so when we have containers, these containers are created from container images. So what we'll do is we'll go through our development cycle, and then that source code will be created, or we'll create a container image from that. And so when we take a look at container images, we have several layers to a container image, and we'll have our base image, and we'll see this in a little bit later how these are built up. But we'll have our base layer, we'll have our OS update layer, we'll have maybe a Java runtime layer, and then we'll have our application layer. And the great thing about containers is each container is self-contained, so you don't have to worry about, I know we talk about, we mentioned Java here in this slide, and if you think about Java applications, and some companies are using the latest and greatest version of Java, and some are stuck back on Java 6, maybe Java 7, maybe not so much Java 7, but there's still a lot of dependencies on like Java 6. And even though it's not a great security, security-wise, it's not a great situation, we're locked in sometimes to what our vendors, or maybe there's some some legacy parts of the application that require those older versions of Java. And so back in the monolithic days, we would have to really, we'd have to work on creating multiple versions of Java on a server. And having a container, since it's self-contained, we don't have to worry about that anymore. We can then package the exact versions of software that we need, the exact versions of applications that that we're working with. And so we don't have to worry about, well, we can only have a certain number, or a certain number of instances of databases before we have to start breaking it up into different servers, or things like that. So it makes it just infinitely more flexible. So putting together an example Java application, we would do that using a Docker file. And what the Docker file does, and we'll go through this a little bit later as well, but it just tells our pipelines how to build these containers. And so it'll have, at the very top, we have our base, we're setting some environment, we're setting up some applications here. It's Java, we're exposing a port, and then we're telling it what needs to, what the command is to run that application. So it all runs in that container. Oh, here we go. So I won't go through, I won't belabor the point anymore. But when we, so when we have all these container images, we want to make sure that these container images are secure, that they're not, they haven't been tampered with. And so what we do is we store these in a container registry, or an image registry. And what an image registry does is it allows us to provide all of the containers, all of the versions. And so when we're going to deploy an application, we can select the version we want to deploy from the image registry, and that allows us to quickly, we can set up like canary testing or blue-green testing, or we can quickly roll back if we deploy a version that's not working properly or not working the way we want it to work. Maybe something happened to the in the development process that slows the application down, and we want to revert back. Having an image registry, we have these images, these container images that we know haven't been tampered with because we keep a checksum value of each container in the registry. So we know they haven't been tampered with. We can do our security scans against them and verify those images. And we can almost think of container images in the image registry like the golden copy, because as we work to deploy these, they're going to be deployed from the image registry. And so once a container gets deployed, they are immutable. So a running container typically can't be changed. And if for some reason, if the container is set up in a way that some things could be changed in it, we can destroy that container and instantiate another container that would have the golden image. So this is where we come in with Kubernetes, because we had this great container technology, but as we start building these and as we start scaling this up, we'll end up with, we could end up with hundreds or thousands or even hundreds of thousands of containers. And so how do we orchestrate this? And that's where Kubernetes came from. Kubernetes really came about as a need to orchestrate all these containers. So as I just stole my own thunder here, Kubernetes is an open source orchestration system for managing containerized workloads. And as a container orchestration system, it can really help you automate your application deployment. It can do scaling. It can do management. So, when we think about an application being up and running, if that application stops responding, Kubernetes, we can design that so that it will recognize that those containers are no longer responding, or they're not responding the way we'd like them to, and we can have them restarted. So we can bring applications up and keep them up for longer periods of time and keep them more stable. So as we move through, we'll start talking more about how Kubernetes objects work. And so Kubernetes is built of a collection of objects. And these are the persistent objects that represent the state, or at least the desired state of your cluster. And so when we think about Kubernetes objects, here's the different objects that we have. So we have pods, and we'll talk about that in just a few minutes. But deployments, namespaces, services, persistent volumes, we have all these things that we can use. And so instead of having this monolithic application, now we can start spinning up, the additional capacity we need. And so, if you think about, like a monolithic application, as you add more load to that application, in the monolithic application days, we had to scale the entire application. We couldn't just scale, say one piece of it. We had to scale the entire thing. And so we ended up with consuming more compute resources for doing things that we really didn't need. So maybe we have an application that as the users increase on it, the need for additional front end services increases, but the load on the database or the load on some of the other services doesn't really increase that much because they're not really pulling much data, or they're not doing a lot of work, or they're not putting a lot of load on the other components. But in a monolithic scenario, we have to scale the whole application to get that one component that we need to have the capacity that we need. So that's where Kubernetes objects really shines through. And so when we think about Kubernetes and creating these objects and managing these objects, we have an API, and it's a REST-based API. And each API call includes these 5 primitives, if you can allow me that. And so we typically have a kind primitive, and the kind primitive will represent the type of object that we're dealing with, and we can create metadata. And we have API version here. We have the spec, which is how we want, what state we desire that to be in, what the configuration of that container is, and then we have a status. And so within a Kubernetes cluster or an OpenShift cluster, OpenShift is a superset of Kubernetes, so it's Kubernetes with a lot of additional functionality built into it. So when I say Kubernetes, we can really think of Kubernetes and OpenShift as synonymous here. But the API provides a way that we can interact with the cluster, and we can control our cluster using that. And so within just a plain Kubernetes cluster, the command, the API is kubectl. And of course, moving to OpenShift, there's a command called OC for OpenShift client. And so when we think about a Kubernetes cluster, there's a couple of different pieces to it. And so we have nodes in the cluster, and these are just machines where this is where the control plane runs of a Kubernetes cluster, and it also runs the workloads. And so this is a great design. It allows us to spread our application across several servers. So now we can have more fault redundancy. Our fault tolerance, I guess I should say. And it allows us to also, as we need to add capacity to that cluster, we're no longer locked into, well, now we have to buy a bigger server and then migrate. With the Kubernetes cluster or OpenShift cluster, we're able to add capacity and then scale that capacity over to those new nodes. And they don't have to be the same size. They can be different sizes depending on our workload. And so it really decouples applications or our workloads from our hardware. So the next thing within the Kubernetes structure is pods. And so if we think about pods, these are really one or more co-located containers. And most of the time we'll have just one container per pod, but there's instances where we'll have multiple containers per pods. And so these pods get scheduled to run on nodes. And here on the screen, we have an example pod spec. And so you'll notice this has the same 5 primitives that it has 4 of the 5 primitives that we talked about before. It has the kind, which tells it it's a pod. It has some metadata information. And then it has our spec. And the spec is really, the name of the container, and then the image that we're using, maybe the ports we're exposing, and other resources that we have. It could have limits and some other stuff in there. So the next, I think I may have jumped a slide. No, so when we think about scheduling these pods, when we talked earlier about them breaking up a monolithic application into microservices, having each container, each pod, when we spin that up, it will get its own IP address within the cluster. And so when we think about trying to address things by IP address, and every time a container is started and restarted, it may get a new IP address within the cluster. And so trying to address things within the cluster, or trying to address containers within the cluster via IP addresses, becomes very problemsome in a Kubernetes environment. And so what came out of that was the ability to create services, and services abstract the IP address, and it kind of hides that under the covers for us. And so we just expose the service, and then the service uses labels to identify which pods are part of that service. And so then the service really acts as a load balancer and uses those label selectors to determine where our traffic should be sent. So here's a service YAML file for our Hello Kubernetes or K8s service. It tells us which ports we're using, protocol, and all that great stuff. So it's really this is really a great building part of Kubernetes. And so then moving on to how we would work with our pods. So we may have instances where we want to have the pods scale up, or we may want to have multiple pods created. And that's where we bring in deployments. And deployments take the pressure off of us of having to go through and specify for every pod that we're creating. And we can create a deployment, and the deployment will tell us how many replicas we want to have. And we can also use things, we can use deployments to do things like auto scaling and some other stuff. So we can also, and deployments are also used for automatic recovery of services. So this is where when a container or when a pod enters a state that we're not happy with, the deployment will go ahead and kill the pod that's not running in the desired state, and it will start a new pod in its place. And so, in the case where we have just one pod running, of course, we're going to, potentially have some service disruption. But for critical services, we can schedule multiple replicas of that, and then we can tell the deployment, or we can specify in the deployment how many pods have to be running at any given time. And so that way, Kubernetes or OpenShift knows not to take down too many pods at the same time when it needs to replace those for whatever reason, whether it's scaling up or whether you had a change in version. So these three components really shine and make Kubernetes and OpenShift deployment very manageable. And so if we think about an application here, or we think about a Kubernetes cluster, here we have our cluster with our control plane, our master nodes. And the control plane is what controls the workload. It does all the scheduling. And then we have our 6 worker nodes, and our workloads are spread across those worker nodes, so that we can potentially have a loss of a node. And I think we'll see this in a couple slides. We can potentially have a loss of a node and not have any loss of service, because if we lose a node or if we lose a pod, those workloads will just get rescheduled to another node within the cluster to retain the service and keep it available for us. So here's a little, just an example screenshot of the deployment where it's scaling up to 4 pods, but there's 2 active pods right now. And within Kubernetes and within OpenShift, we can easily scale up or down manually if we wanted to. But the power is in being able to automatically scale when we have, say, a increased capacity or increased demand for that capacity, and to also scale down. So if we think about applications where we may have peak use times. So let's just say, or let's just think about our morning routine when we start work. I know I used to say when we come into the office, but since most of us aren't coming into the office yet, we're all working from home. But we generally all start working around the same time, and we all check our email, and so the demand for that service goes way up for the first couple of hours of the day, and then it kind of drops off. And then as we get into the evening hours, that demand drops off significantly. And so rather than having a ton of capacity just sitting there idle, we're able to orchestrate this through our Kubernetes cluster and scale up and down to automatically reflect our the current workload. And so, just as an example, we have our Tomcat application running, and we have 4 replicas of this pod running, or we have 4 pods running as the replicas. And so, we're using the service to provide load balancing across all 4 of these. And we can set up a couple of different load balancing scenarios, but this ensures that customers receive, or users of the application, I guess we could say, users of the application have a uniform experience. And so, as load increases on one Tomcat, it just shifts new traffic over to another one, and then just keeps doing that. And so we can do, something like a load-based balancing, or we can do round robin, or all of the different technologies there. So if we look at the situation where one of these pods fail, the Kubernetes cluster is going to go ahead and see that that pod failed, and it's going to take it out of the load balancing scheme. So now we don't have the situation where customer users of that application, I know I keep saying customers, but a lot of times we're in that mindset, but users of the application, instead of getting that 404 or maybe a 502 or some of these other errors for the application, if it's a web application, of course, but if it's not a web application, maybe something else, instead of getting errors that the application is unavailable, having multiple copies of that container pod running makes it so that the users really don't see that or don't notice that impact. And so when we have a pod failure, Kubernetes or OpenShift will just reschedule that onto another one of the nodes, worker nodes within the cluster that has capacity to take that. And so that really helps out with the user experience. And so then if we think about a node failure where a whole node goes down, we have these 3 applications running on it. And so when we have a complete node failure, Kubernetes will go ahead and reschedule those workloads onto the remaining nodes that are there. And it gives you an opportunity, it gives the operations teams time to diagnose the failure. And if they need to replace the node, they can quickly do that, or they can bring the node back up without it affecting the user experience, without affecting those services. So a very powerful thing that we have within Kubernetes to control our applications. And so now we'll just talk a little bit about some of the workshop modules. And I promise I'm getting to the end. So we have our Parks Map application, and so this is just a basic idea of what the application looks like. And so we have a web piece to the application that our users will connect to the application from, and then we have our national parks backend, and then we have our Major League Baseball parks backend, and we can have additional backends depending on what the application is calling. So if we look at that third box on the right, we could just continue adding additional services as we need to. So this is the great thing about microservices, is that since each of these backends are discrete processes running, we don't have to worry about those backends colliding with each other, or having issues with compatibility. Each one of them is running independently of each other. And so I won't I won't spend too much time reading off the slide, but this is a Spring Boot front end using some JavaScript, and it has a world map with some data points, and then we have a Kubernetes Java client to list objects and to react to events such as new backend adding. And so this is on the left side, this is what the deployment configuration would look like for our Parks map application, and we'll see this as we go through it. And then on the right side, this is just a little screenshot of what the application looks like. But the if we think about the front end deployment, this is really, we're deploying this as a container image, and it's being deployed in an agnostic way. So within our workshop, we have a few different language choices that you can choose from. So when we get to the workshop selector, feel free to choose the language that you're comfortable with or that you're currently using. Our workshop, I think it's got Java, Node.js. I want to say .NET, but I don't quote me on that. And then I think there's maybe a Python. So there's a few options to choose from. So we'll throw the link out into chat in a few minutes for selecting which workshop. So we're going to be doing all of the examples in Node.js. So there might be some slight differences in some of the intermediate commands or intermediate ways that something's happening, but it's going to be very similar across all the different languages. So if you choose something different than the Node.js, then you'll see that. So yeah. So I guess I stole my thunder again, but yeah, at the bottom here it shows that we have Java, Node.js, Python, and .NET. So our backends, we have a Mongo database, and then we're exposing that through REST APIs to the front end. So this is a pretty strong workshop environment, and we're also going to be showing you how to use OpenShift's source to image. And so this is a way that we can automatically, or we can include this in our DevOps pipeline to automatically build code once it reaches the stage where we want to do that. And so there's just a couple more screenshots, but we'll have within the application, we have health check set up. We're going to be looking at some of the automation with pipelines, and we're also going to be taking a look at webhooks. And so let's see. So this is just an example of our Java backend for the Major League Baseball parks. And this is going to show how we can use OpenShift to run legacy apps that we might have. And so, we're going to be going through this where we're going to build our artifacts, and then we're going to create and deploy those container images with source to image. So all right. So that's the end of the slides. So I'm going to bring Jory on now. And Jory, do you have the link to the workshop?
I do. I was just waiting for you to be done to send it.
Fantastic. Well, thanks for participating my part of the show. And I'll be hanging around and helping and working with Jory. Jory and I'll be working together on the lab. I'll be a little bit in the background, but Jory's getting ready to throw out the link to the workshop. And once he does that, then I will hand it over to him.
Gone ahead and thrown that in chat.
All right. Well, I can let's see what I got going on here. Just bear with me for a minute. All right. Let's see. So while Jory's getting everything on his side together, so when you go to the web page, or when you go to the workshop page, you'll see here's the ability to choose which language you want to work with. So like I said before, choose the one that you're comfortable with or that you're currently working with. If you want to try something new, hey, this is a great learning environment. So we all have our own space within the cluster, so we're not going to collide with each other. So like I said, you can choose whichever one you want, but when you choose a workshop, you'll be brought to a login page, and so now we need to assign user IDs to each one of you. So I believe the first user ID is Jory, is it just user 1?
Yeah, and I actually have this covered now. If you want, Marshall, I found
Okay.
something good for this part.
Perfect. I will. I'll stop sharing and pass it over to you. So.
Awesome. Okay, so Marshall already kind of explained here, and we're gonna go with the Node.js workshop. I'll just switch screens. So this is another service within OpenShift right now. So I went ahead and I went off the attendee list and started marking people's names by users. I can read them off just to make it easy if we need to. Dustin, if you're still on, you're going to be user 1. David Charles, if you're still on, you're going to be user 2. And I do apologize if I butcher any names. User 3, Gorov. User 4, Maha. User 5, Scott Daniels. User 6, Robert Gornick. Marshall, you can be 7 if you want to.
All right. Lucky number 7.
Yeah. And user 8 will be Alex Coos. And user 9, Armando, if you want to join in. And I'll keep an eye on the attendee list. So if anyone else joins, we have plenty of users to use. So, and most important part is you have the usernames now. You do need the password, which is going to be all the same for everyone. And I'm putting it all in chat, which is just OpenShift. Now, each of these labs are going to be custom to your user. So you'll notice mine just shows up as OpenTLC MGR. So if you see any steps in here that just say the username on my screen, remember that's my username, not yours. And if we're good to go ahead and start, I think is anyone having issues so far, or would you like me to go ahead and proceed?
Hey, Jory, I tried with my username and password OpenShift, but it is not letting me in.
Okay, it was user 1, right? Or
user 3.
User 3, okay.
And password, the user ID is Gaurav, right? And password is OpenShift.
No, the password is actually going to be the user and the number. So you said user 3, so the username is user 3.
Okay, username is user 3 and password is only just OpenShift. Okay.
Correct.
Yes, I am in now. Yeah, thank you.
Awesome, glad to hear it. Anyone else, or are we? Okay. Well, so here's our fancy homeroom lab, and adjust as you see fit. If you want to make this window bigger, move the terminals. You do get 2 terminals. One thing I will warn you is throughout the exercise is there's going to be buttons where you can run commands. it will run where you have it last selected. So if you started typing on the top and you accidentally come down here, your command's going to run down here. All right. So we're going to go. I'm not going to go ahead and read all this, but basically we are going to go through OpenShift. So as Marshall said, it was the superset of Kubernetes. So we're going to show you all the superpowers of OpenShift. So if you go to environment overview, this is at least going to tell us what our environment looks like. So we're going to have a master node, some infrastructure nodes, some workers, or also known as application nodes, and an NFS server, so for storage. And the infrastructure node is providing a few different services. It's actually providing the information we have here. It's actually hosting a registry, the router, and a Git server. So notice right here, this is saying OpenTLC Manager on my screen. That is my username, so it'll be different for every user, everybody who's logged in. And let's go ahead and get rolling. So this is just a quick overview on Homeroom. This is just the service hosting the lab. And right here, this is kind of what I mentioned earlier, the little play button. So if I click over here, I press play, it'll run the command over here. And for example, if I come down here and I run the command down here, it's going to be down here. So, so be mindful of that because they are separate sessions. So if you need one thing in the same session, it might get confused. And right here is just a quick normal clipboard symbol. So it's just copying it. And those are the important things on that. So let's get rolling. So here's the architecture. Kind of already discussed that with Marshall, but so I won't go too deep into it. That was short. All right, so sorry.
Hey, Jory, did we want to take a 10-minute break to give everyone a chance to refill their coffee and our maybe some water?
Great idea.
Work-approved drink. So and then we can head into the first exercise.
Yeah, that's a great idea. Thank you for reminding me. Well, as Marshall said, let's go ahead and take a quick 10-minute break. I'll start the timer here, and I'll be around in case you guys have questions in the meantime.
Hey Jory, this is Gaurav again. So I am able to use using that home room. I'm able to hit that date. That is on my first terminal. But by next, the second half terminal don't have any user ID or something. So I cannot switch on to second one.
Okay, so no worries.
Yeah, so you have to, you have to, but for me, just top one is working.
Okay, so it shouldn't be a problem if the second one's not working, but if you want to try, right here in the hamburger, there is a reload terminal button. You can try reloading the terminal. That should hopefully fix that.
No, I think both went away. So let me try one more time. No, I am not able to see now my user. No, I think both is not working.
Since we haven't started anything, I would go ahead and run.
Oh, now it's working. Yeah, it's got it. Yeah,
okay.
Yeah, it's coming. Yeah, thank you.
No problem. Okay. We're just going to start off by showing the command line real quick. So pretty simple. OC help. OC is the OpenShift Open Container. I forgot what it. OpenShift cluster. That's our command line tool we're going to be using, and it right off the bat it does have help. So it'll give you the basics, and if you need more help, so for example, there's OC login. Let's just do add help again, and it'll give you more. So help is your friend. So for each user, we're going to have a project that's going to be named your username. So for me, it'll be OC project open. Wait, there we go. So it automatically connects to that user. For you guys, it'll be your open OC project, your username. So if you're user 1, you'll be user 1. So that's just how to do it on the command line. And now we're going to go ahead and show you in the actual OpenShift console, one of the breads and butters of it. Okay, so to log in, it's going to be the same username and password you had. So it'll be, for me, it was OpenTLC Manager, and OpenShift is the password. So again, if you're user 1, that's your user, and your password is OpenShift. So if this is your first time in the web console, you're going to see the list of just how everything's looking. And in projects, you won't see this many projects. You should only see your own. So for example, you should only see user and your number. And that's what you'll be working through for most of this one. So in my case, you're gonna click your project. So now we're looking at the actual details of the project. So it's going to list how everything's running and so and so. Let's expand it so you can see it. So right now, as you can tell, we have nothing going on. We have nothing set up in the project yet, which is what we're going to be doing today. One thing to note is, so we do have a tab. So you guys are administrators and developers, so you'll have both perspectives. So we just kind of looked at the administrator. So if we go into developer, if you want to do the tour, feel free. In this case, I'm going to go ahead and skip it. So right here, this is the topology. So this is your starting point. Since we don't really have anything, this is where you can start to figure out what you want. So for example, if you wanted to install something from our catalog, a database-wise, you can start pulling it right from here. We have multiple options with OpenShift. And that's the quick intro. So right off the bat, let's go ahead and deploy our first image. We're going to do it from the console. So we're going to stay as developer, and we are actually going to go to all items, and there we go. Now I can see it. We're going to go and click container image. And if you want to, you can also search. I need to go back a little. There we go. So container image. And we're going to follow the guide. So in this case, it's going to be Quay.io. And Quay.io is actually the image registry or container registry. And this is just the path within it. And this will be the name of the container. Sorry, the image. And this will be the latest version of it. And in the runtime icon, we're going to mark it as it'll be using OpenShift topology. If you were to use others, you have that option. And we're just going to go ahead and take the default name. You can put it as Parks Map app, or the doc says just Parks app or Parks Map. And down in resources, sorry, the application name is going to be workshop, and the name of it will be Parks Map, like that. Now, from the resource section, we're going to want to do deployment. And we are going to uncheck the create route to application. And what this does, it actually will automatically expose it to the public. And right now, we're actually going to do that later on manually, so we can show you how easy it is to do. So from there, we are good to click create. So right off the bat, you can tell how easy it is to build an application. We already have one now. Let's go ahead and click it. So you can right click and you can start looking at everything. So for example, by default, here's our labels. So this is kind of parts of the metadata we can call later. And so now that we have it, let's go ahead and click cancel. So now we're going to look deeper into it at the pod count. So this is our opportunity. So if you wanted to scale up and scale down, you can. You could plus, minus right there. There it is. So here's the details of what we have currently. Another place where you can up the pod count. Labels. So here's where your max unavailable. So 25% of one pod is unavailable. It can only take the maximum of 25% of each pod. So if you have multiple pods and it's using heavy utilization, it can only use a certain amount of that pod before it needs to move over to another. So if we switch back to the administrator view, and we go over to pods, we can see we have the pod running right here. And now that we've kind of looked at it from the console, let's go ahead and look at it from the command line. So again, the play button will just run the command for you. So right here, as you can see, we have our new pod created. It's been up for about 2 minutes and it's ready, which means the containers are running within the pod. And it does look similar to this output. So for this part here, we are actually going to write this manually. So what we're going to do is we're going to grab this name of the pod. I'm going to do it manually. What this is going to do is it's going to display the details of the pod in a YAML format. And with YAML, it's a lot easier to read. So if we start from the top here, scroll up. So before I get too deep into the top of this, is everyone comfortable? Is there any questions so far? Feel free to interrupt me. I'll take the silence as everyone is okay. So going down, here's the first version of the pod. We can tell by kind it is a pod. And here's the different metadata we have with it. So we can easily see which interface it is and the IP address of this pod. Well, we have a lot of information here, so I don't want to go through all of it because that could take a while. So our name of the application. Alrighty, so let's go ahead and scroll down and we'll point things out as we go. So this is the namespace, just to reiterate what that is. That's kind of the project. So the namespace is your usernames, so where everything is hosted at. Your replica set, so it's how many, this is the brains of all your replicating. So if this is you scaling up and down your pods. So this will be how it knows what number it needs to have. And here's the container within your pod and all its config, the name of it, the ports we're using, the limits on the CPU. So if it hits 500 meg in CPU, it will create another if needed, or stop itself and restart. And memory limits. And it's going by user ID, so it knows what user it needs to actually start as. And just note it's using default service accounts, which we may edit later. And just the IP address of the actual host, and so the node it's running on, and the IP address of the pod itself. So each pod will have its own IP address, and this is just one of them. And so while we see this here, we can also see that in the console as well.
Yeah, and hey, Jory, at this point, do we want to just check with everyone and make sure everyone's keeping up?
Sure, of course.
Yeah, so just you know, if you're working along and if you've fallen a little behind, just throw a note in the chat, or can we just get a show of hands if you're not if you haven't caught up to where Jory's at, and if you haven't, we'll slow down and let you catch up.
Again,
So,
please interrupt us if we're going too fast. We're happy to slow down and go back over something if you want us to.
yeah, definitely. And so yeah, I don't see any hands raised, but so it looks like everyone's caught up so far, Jory. So I'll let you get back to it.
Okay. All right, so we were just going to kind of show what we did in the command line, but we're going to show it in the GUI. So we are going to go to the developer perspective over here, and we're going to look at your topology so we can see your application. And now that we can see the details of it, we are going to select the resources tab. And so right now you can tell we only have one pod, and you can tell what port it's using here. And if you click here in the service, it should show you the IP address. And that YAML output we just saw a minute ago, we can actually view it here. And just additional details about when the pod started and how long it's been around.
Hey Jory, Gaurav this side. Last screen you showed that we have cluster, right? So currently we didn't add in anything, right, to the cluster, but by default it is getting cluster added with only one node.
Correct. So we haven't added anything. We're just showing things off right now.
Okay.
But yes, this came by default when we actually installed the Parks Map application.
Okay.
Okay, well, let's kind of we'll show off services next. So the services are actually, as even Marshall said, it's kind of like a router. So it's going to route to which pod is least loaded. So if we go in command line, let's just clear it so we have can see it nicely. So here we are, we got the service that's running, its IP address, and notice we don't have an external IP, and that's because we unchecked that first box when we were creating it, and what ports we're listening on. So if we go back over to here, under the development perspective,
Yeah, Jory, and that's that's an important part to think about. As developers, when we're developing applications, we don't have to expose the whole application, or all the pieces of the application to the external world. And so when that piece says there's no external route, then it's just within the cluster itself. And so the OpenShift security really protects that application and all those things. So we could think of it really as like a little private network that these are running on until we expose the services to the public or to the external network.
exactly.
Okay. Yeah. Jody, one question one more time, right? Again, because
Sure.
when we started our overview, we discussed that we have a master which is controlling all the nodes, right? So when we are creating any application, so this is our development environment, we can say, and the backend side, your master as well as the node is getting created, right? Because that's what we are able to see pod, and pod have one container. So I can say we have only one master controller, and then there is only one node. So this is the right master and slave.
Correct. We are using one master and one slave in this instance, and right now we only have one pod that contains one container.
Yeah. Thank you.
No problem.
Yeah, Gaurav, within a production OpenShift cluster, we'd actually have a larger footprint, so that so OpenShift is more resilient, and so when we have more master nodes, they form a quorum together, and so one of the masters will take over as the leader, but the other masters that are in the cluster will constantly monitor each other. And so if one of the masters fails, then we don't lose the ability to schedule and keep these pods running. And we don't lose the orchestration capabilities that OpenShift provides.
Right. Because the Kubernetes is the same, right? When one of the master node is down, the slaves will get auto elected, and one of the slave will become master. Okay.
Yeah, I mean, there's a few different ways to set up the architecture. As developers, the nice thing about it is you don't have to worry about that. You can develop your applications because you're really abstracting the development process from the underlying hardware OS that is being deployed. So you don't have to worry. As a developer, you don't have to worry anymore about what's the operating environment going to be that I'm going to be serving on this. So OpenShift really allows you as a developer, it frees you to develop applications without having to worry about, well, what's the library is going to be on the underlying server, or which server am I going to be deploying this on. And so that's one of the great things about OpenShift is that abstraction of the hardware from our software environments.
Yep, right. Yeah, that is a good information. Maybe this is the off topic as per our current workshop. Is the Red Hat is providing all these manage cluster, because as an organization, right, we do not want to manage all these clusters. So there is any way that the Red Hat is providing that support, because say these are cluster is down, so we should not have to take care of that one. We can call Red Hat and they can take care of that. So is that something we have with Red Hat?
Yeah, definitely.
Okay.
So Red Hat has a partnership with all of the major cloud providers. So AWS, Google, IBM Cloud, Azure, and so you can purchase a let's say a managed OpenShift cluster, so that you don't have to manage that. But when when you talk about having it more of a SaaS option, there's each of the cloud providers are a little bit different, and I can't remember all of the ins and outs. We can definitely get those to you, because each cloud provider is slightly different. But for the most part, the cloud providers manage the master and manage the control plane. So if when we say master, if you think of the Kubernetes control plane, the part that does the scheduling of pods and keeps the pods up and running, typically the cloud provider will manage the control plane for you, and so you don't have to worry about that at all. And then you just add worker nodes for the amount of workload that you're adding to it. So it really makes it nice in that regard, that you're not managing, you're not managing hardware resources, because the cloud provider does that, and then B, the cloud provider is also managing the OpenShift platform, so that you don't have to worry about keeping that up and running. And there's a strong partnership between Red Hat and all of the major cloud providers. And there's like 9 or 10 that participate this way, and Red Hat's adding new providers all the time. So I think like Alibaba's on the list, and some of the other cloud providers that aren't the 2 or 3 major ones that we hear all the time are the Google, Azure, and AWS. But there's a whole ton of those, and so that that really makes it nice for that situation where you're saying like you don't want to have to manage OpenShift. You just want to be able to use it and develop and deploy your workloads.
Yeah, thank you.
Yeah, no problem.
All right. Where were we? All right, so we were looking at the development perspective here, and we were just gonna show off the resources of the pod, and notice that we are actually utilizing resources this time. So we're using a little over 40 kilobytes of the file system space, and what's coming in and out of the network ports, and just we're not using a lot of memory or CPU. So we can tell pretty easily that the pod is not really eating too much resources. Now, if we come back to YAML, we can actually look at the output just to confirm the config of the pod, where it's pulling everything from. And if you wanted to, you could actually edit in this view as well. Notice all of the IP information, but I'm going to click cancel in case I added any.
Yeah, and Jory, if I can interrupt you
Yeah.
for just a minute. And so, if you notice throughout the workshop, we're kind of bouncing between command line and the OpenShift console. And one of the reasons why we set the workshop up this way is so that you can see, kind of the that we can do it in both environments. So, if you're a command line person and you're really, that's how you operate, you can do everything on the command line, or you can, if you're more of a, a GUI person and you don't want to, have to remember all the switches and all the options, you can also do it in the OpenShift console. So, a couple different ways. And so we want, we built the workshop to show both ways, so that, so you can kind of get that immersion of, using both environments, how they work, they're really interchangeable for most things. There's just a very small amount of things that you have to do or that need to be done on the command line. So I just wanted to throw that out there in case you're wondering, like, well, why are we switching? But it seems like kind of a pain in the rear to have to switch between the command line and the console. So thanks a lot, Jory. Thanks for letting me throw my commentary in there.
Yeah, interrupt anytime. Okay, where were we? Okay, I think we're switching back to command line. All right, so we're just looking at it in the console there. So quick OC get pods. And right now we're just confirming we're comparing outputs between the console and our view here. Did I hear a question coming?
No, it's okay. Just you misspelled that one. So
yeah, I started looking at the wrong one. There we go. So again, we can view the detailed of each pod. And if we're gonna go find the metadata section here. All right, so here's metadata, and now we're gonna find the labels. So right here. And right now we're just confirming one, we're matching the output we've seen there. And also this is the same output we've seen in the console. Now to dig deeper into the service, we'll go ahead and just look at specifics. So notice that these labels match what we just saw. And let's go ahead and move on to the fun part. So this is actually, we're gonna finally actually get to see it scale. So for starters, let's go ahead and do get deployment. So here's our parse map deployment. We have 1 out of 1 right now. It's been up for about half an hour. And here's our replica set. So what our replicas are configured to. So we only have one set. So this would be our opportunity to scale up if we wanted to. And we'll do it through command line, and we will then change it again in the console. So we went ahead and we set it to 2. So if we wanted to, we can do the RS again, and notice it's changed. So now let's go back to the console and actually verify it's changed there as well. So from the topology view, if you click here, notice we have 2 pods running now. And from here, we could easily go up or down.
Something that would help to, Jory, this is Armando talking, is can you point out the differences between OpenShift and between Kubernetes? So if we were doing this in Kubernetes, it would be done this way. And here's some of the additional management tools that OpenShift provides, just so we can kind of tell what the differences are. And of course, the value add with OpenShift.
Yeah, I can try here on that. I don't have all those commands in front of me at this time, and it would take me a minute to figure those out. But one of the biggest benefits of OpenShift is it adds on to Kubernetes. You get these extra commands with it, and also you do have a GUI here, whereas Kubernetes does not. So if you don't know the command line, you don't want to know the command line, you do have the opportunity to come into this console and pretty much manage everything from here.
Yeah, and Jory, I'll kind of pile on to that. You know, so when we think about a Kubernetes cluster, you know, when you install Kubernetes, the open source version of Kubernetes, that's all it is just the container or the pod scheduling and orchestration piece. And so if we think about what we need to do to a Kubernetes cluster to make it, let's say, enterprise ready. So within, and there's also, you know, I'll talk about this in just a couple minutes, but you know, so if we had just a pure, you know, if we just installed Kubernetes from the open source software, you know, Kubernetes is a Google project. They're the primary contributor to that project. And Red Hat is the #2 contributor to the Kubernetes project. And so the open source Kubernetes, it doesn't have things like, you know, identity access management. It doesn't have networking. It doesn't have all of these things built into it. These are things you have to add on. And so there's all these different products. And, you know, if we remember back to our beginning slide, you know, Armando talked about all the different technologies that that we specialize in. You would have to add all those in. You know, there's a lot of different components that are built into OpenShift that aren't provided in Kubernetes. So you'd have to add all those in manually, integrate them all manually to get your Kubernetes cluster to be enterprise ready. And then the other part about Kubernetes is, you know, so this is a little bit of a, you know, a difference of opinion between Google and Red Hat. And so within a Kubernetes cluster, everything is open by default. And so it has the least restrictive security policy. And then when you think about, and so when Red Hat built OpenShift, and so OpenShift is just a, you know, it's the base Kubernetes platform that's built, that they've built upon to make it enterprise ready. And so, so the base Kubernetes image is completely open. Everything's turned on. Everybody can access everything. Pods can talk to each other. You know, there's very little security that's enabled by default. And what Red Hat did when they looked at it, they said, you know, there's hundreds, maybe thousands of options you would have to go in and turn off to make it secure. So what we're going to do is we're going to make it the most restrictive out of the box, and then you can turn those things on that you need. And so if you think about, you know, the idea, you know, let's say you, you know, let's equate this to like an office building with 1,000 doors. It's a lot easier to go through and open the 3 or 4 doors that you need, rather than going through the entire building and locking the 950 that you don't need, or the 995 that you don't need. And so that's kind of the, you know, the difference of opinion between Google and Red Hat. But that's, you know, really the difference. You know, so when we think of, you know, when we're talking about the command line and we have the OC command, that OC command is really a superset of the kubectl command. So there's this command that's called kubectl. We, you know, in the Kubernetes community, we call it kubectl. And so all the commands that you can run, you know, all the commands we're running on with the OC command, you can run most of those commands with the kubectl command. And I'm not sure if it's installed in this environment. I think it has to be. But there's a few OpenShift specific things, you know, so there's additional technology that OpenShift has developed, or that Red Hat has developed. And so the OC command includes those additional things that are OpenShift specific, whereas the kubectl command is just the base Kubernetes command line tool. So hopefully, Armando, is that a little more of a great explanation, or a little better of an explanation for you?
Yeah, I was just wanting to make sure that there was some understanding of the differences between what was available in Kubernetes and then what Red Hat built into OpenShift. And then if there's any questions, of course, from the Red attendees, if they have a question of how this works in Kubernetes or OpenShift, please stop us at any time and ask that question. Thank you, Marshall, for explaining that.
Yeah, no worries. All right, Jory, back to the show.
Okay. So we left off, we scaled up our pods. And so now we showed that we had 2 pods in the console. So now we're going to come back to the command line here. And let's clear it so we can read it. So get pods, notice we do have 2. And notice this one here is new. It's only been around for about 7 minutes. And the other one's been around for about half an hour. So if we wait, forget about that play button. So one thing to note out of this output is we have 2 IP addresses now. So each pod has its own IP address now, and they're both listening on port 8080, which is fine because all the external traffic will just route to one of these. And notice the labels are the same. Everything's the same for the most part, minus you have more than one IP address. And just another add-on to the command is you can actually say if you want something specific out of describing a service, you can get that. It's like, hey, I just want the endpoint IP addresses. You can. And now if we switch back to the console again, we can come in here and we can go to the service. It's in here somewhere. Go to each one, we should be able to see the IP address. Yeah, here we go. Here's the pod IP address. So you have to go dig into each pod to see each IP address. Okay, so here's going to be the fun one where we actually get to watch it heal itself. So what we're going to do is we're going to actually delete a pod. So we're going to do an OC get pods, and we're going to see what we have running. I'm sorry, I got to actually type this manually. It won't let me copy it in. So in this case, we are going to break the newer pod. So we're going to go ahead and delete it and also try to catch it, create a new pod or see it go down. So now I will be honest, it does happen pretty fast. So we may not see it catch it disappear, but we should see a new pod with a different age. Okay, so as you can tell, we were not able to catch it just be fully deleted. We did get the little delete here. But one thing to note is, okay, we have a new container. It's been up for about 11 seconds, and it has a different ID. So that is our indication, hey, this is a brand new one. It did, after one was broken, it came back up as something else. So now we're going to go ahead and scale it down. The reason we're scaling it down is apparently the coding of this application was not actually meant to be scaled to 2. So we're going to scale it down so we can continue the lab properly. And we have a couple ways to do that. We could go through the command line, or we could go through the console. And I'm going to go through the console to show it off and just show how easy it is. And you'll notice it start to go down. So we now only have one pod running. And extra confirmation here. we are down to 1, and we're running the oldest one. Alrighty. So now here's where we're going to actually make this allow people to hit our applications from the outside world. So that we're going to create what's called a route. Now there are, again, 2 ways to do this, because we can do this through the command line or we can do this through the console. First way we're going to do is we're going to do it through the console. So we're going to go to the administrator view. And we are going to go to routes. And we're going to create a route here. So we'll just go ahead and parks map will follow suit. And the service field. And 8080. So notice it actually did pull in some of that information on its own. It was actually reading the YAML file to pull it back in. And for security, we are going to go ahead and secure it as best we can. And we're going to select edge, so meaning it will be accessible from the edge, the outside world. And we're going to go ahead and basically leave everything blank at this point. And we're going to click create. So now right off the bat, notice we have a URL here. This is the actual URL we could use to connect to it. And before we do that, let me just show you the command line side of it. Okay, so we're not going to create it, but we will follow along until as far as we can for now. No, wait. Let's move this up so we can read it. So notice we now have a route here. And we also have the URL we can use to get there right from the command line. Now, if we do OC get services, we can see that the external IP is not showing. And if you run the create command, it will tell you, hey, it's already out here. And if we get route once again, it shows that. So basically all we did was we confirmed that it exists. And now as another example, let's go ahead and click the URL. So now you can see that it does work, it is running, and it is external. And all right, so this is more towards your troubleshooting when you need to look into your container issues. So first thing is, like, how do we get the logs? Because you right off the bat, you don't know how to troubleshoot containers potentially. So we can go to, we'll go to the developer's perspective, select the application. And we will go to, so here's the pod here, and we're going to click view logs. So it'll take you right to the location where the logs are at. So a quick, easy view, and it'll tell you, it'll start from when that container came up. Notice we do have a couple errors. That is okay. We are probably going to be troubleshooting some of this as a part of the workshop. Now from command line, we do have the ability to get the logs too. So if we do an OC get pods, we do an OC logs, pretty simple. We just have to call the pod name. In my opinion, it was easier to read in the other view, but to each their own. It really depends on the terminal size at that point. So that's how you can look at the logs. And again, there are a couple errors in here, but we are going to solve some of those with later labs within the workshop. So far, is everyone still with me? Any questions, comments, concerns?
No question from my side.
All right, so here's the pretty good one, role-based access control. So right now, with Kubernetes alone and just OpenShift command line, you don't want everyone getting onto your backend node to do everything and touch all the containers, right? So if you have multiple applications hosted on your Kubernetes clusters or your OpenShift clusters, you don't want everyone looking at applications that they don't need to look at. With role-based access control, it actually will allow you to have proper user management. So you can basically say, okay, this development team who owns this application will only see this application. So that way you don't have anyone going into the application that they shouldn't be going into and accidentally doing something wrong, which it does happen with human error. So we are going to go ahead and look at the service accounts here. So we're going to go to the administrator perspective. And user management. We're going to role bindings. Actually, wait. So yeah, we're going to go find our namespace for this. So in my case, bear with me.
Hey, Troy, I just wanted to do a time check. We're getting ready for a break when you get to the next logical stopping point.
Yeah, sounds like a good plan. Bear with me. I'm looking at a smaller screen right now. Okay, so here we go. Okay, so how about we go ahead and take a break and I will fumble around during the break. And then I will continue this exercise so I can get it right for you guys. That being said, all right, if you want to go ahead and take a break, as Marshall said, go ahead and refill your work approved beverages and anything else you need to do.
All right. Hey, thanks a lot, Jory. This is a great presentation so far. And just, as a check, if you're having any challenges or if you've fallen behind, I know we're all busy and you may have had to step away for a few minutes. If you're in that situation, if you're behind for whatever reason, I'm not going to say, like you're behind because you're not smart enough, but because we're all smart people here. But I know your time is, you're being pulled in several directions at once. So, if you have fallen behind, just ping myself or Jory, and we'll work on getting you caught back up so that you can participate in a meaningful way. But or if you're having any other challenges, just pop us a chat, or you can throw something in the Q&A, or you can just go off mute and ask. So, all right, and we'll see you in about 10 minutes.
All righty, welcome back. While everyone was away, I did figure out where it went wrong. I was wrong. It is the developer perspective. So go in there. You're going to go to your topology here. And once you click your application, we will actually click the namespace title here. And if you click role bindings, all we're doing is you can easily look at it and say, hey, okay, this role here is just a user. You have your service accounts. You have actual groups. That's all we're actually looking at the moment. And the next part of this exercise is actually we're going to create a user, essentially. Alrighty, and windows are getting a little cluttered, so let's do that. So let's just confirm we're in the right project. So good news, we're already there. And if we run this, we're gonna just doing a look at OC policy add role to user. We're adding the view role to the default user. And if we go back down, go back here, we should be able to see that extra role in there. So if we find our user, back in workloads, deployments, the namespace, and we should be able to find over here we have the new view role for the default user, and it's only associated to this namespace. Now we could have done this via the console here, and I'll walk through the steps, but we won't actually click the final create button. So this would have been view. And this would be also view. And we're service account. So this is the other way we would have done the last command we just ran. So again, it's errored because we already created it on command line. And now that we did that, we actually want to go ahead and roll out the update we just made. So using the play button, it's restarting the actual applications. So now if we go back over here, we should be able to see that the pod has a different timing on it. Yep, created at less than a minute ago. So it did restart as we expected. Now this, if we wanted to, we can just add the view role to our current user. Feel free to do that if you so choose. So it's optional, so you don't have to. Okay, so is everyone good? Any questions, comments, concerns before we move on to the next one? Okay. So we're going to actually get into our containers command line. So for example, sometimes we have all this access to the containers without going actually into it. So sometimes you want to go do a deeper dive, whether it be troubleshooting or other things like that. So in this case, let's do an OC get pods. And we're going to do OC RSH, so it's remote shell. And so now we're actually logged into the container. Now, the thing to remember is it is a container. It's still Linux. It's just only has a certain amount of things installed. It's got the bare minimum out there. Just to look at what it kind of looks like, it looks pretty much like a normal Linux node from that view. And now, let's go ahead and you can do it from the web console as well. So we are already here. So let's go back to pods. So we have to do it from here. Resources, pods, terminal. Yes, I did just miss that. But yeah, same thing. So if you didn't want to actually log into the container, you don't have to. You just want to run a command against it just to make sure a file has landed there. You can do that. So we'll just show you how. And so all we're doing is we're saying OpenShift execute against this container, and we're actually putting in the command. Now it's not there purely because I don't. Oh, it is there. So I mistyped the pod. Oops, I enter the whole pod in there. There we go. So again, you can run a command against it. You just have to have that pod name. We are limited with the web browser where I can't easily copy and paste. But you can also still run it this way with the RSH. To save time and a little bit of sanity, do that. So I can run commands that way as well. All right, so let's actually create an application. So we're going to actually go back to the console. And in the developer perspective, we are going to go to add, and we're going to choose from Git. So having Git will definitely allow you the luxury of being able to keeping all your code in a source managed location. So in this case, again, you might have a different URL than I. So for right now, we do see this error. That's okay. Just ignore it for now. We will get back to it. Other is fine here. It'll detect. And we'll just mark it down as it will be built as a Node.js application. So now if we scroll down to this section, we'll just fill in what they want. So it'll be workshop. We'll name it national parks. And resources will be deployment. And we will go ahead and add the pipeline. And in case you want to see the visualization, how it's going to actually work once we click build. Create button. Alrighty, and we are going to go ahead and by default just go ahead and expose it to the world. And there we go. We now have 2 applications on our OpenShift cluster. So if we go ahead in here, it is still working. So the nice thing is you can monitor the build while it works. And notice we already have an error, which I believe we're about to resolve with the next few steps. And while that's going on, we will try it from the command line, or at least monitor it from the command line. So right off the bat, it failed. And it does not match there. So the bright side is though we can look here at the logs to try to figure out what went wrong. And so it looks like it did have an issue with the repository that we saw earlier, which we did expect. Now, bear with me. Let's see if we fixed it.
Yeah, Jory, and this is the, the nice thing, as you're developing applications on OpenShift, as you make changes to the application, OpenShift recognizes those changes and automatically starts updating those things. So, as you're, doing your development cycle and you're building these things, you don't have to, and this is especially, nice where you can set up your pipelines so that this can happen. A lot of this stuff can happen automatically as well, but you don't have to go in and recompile and redeploy. A lot of these things OpenShift will automatically recognize a change and update the configuration, update the environment so that you can move through the development cycle quickly, or more quickly than you could with the traditional development methods. Hopefully my colorful commentary gave it a little more time to throw out there.
Appreciate that. Fixing it, hopefully. We like to make sure all developers can actually do the troubleshooting too. So that's why we did plan this. So this is the actual pod of the GOGS lab that we're looking for.
All right. So, as usually happens in workshops and live demos and all that great stuff, sometimes things don't work exactly. Is anybody else having the same problem that Jory's having on the screen? Is the service all the way down? or is it just maybe an instance thing?
Feeling like the service is down, but I'm trying to confirm.
Yeah, since we all have our own namespaces in the cluster, sometimes every once in a while, one of the environments kind of starts acting up, or so let's see. If you just want to raise your hand if you're having the same problem, and we'll do a little dance in the back end and see if we can either figure out a workaround or get back on track.
Okay, the service is up. Okay, there's the problem. Okay, so here's the issue. It's only happening to me. So right now, the OpenTLC-MGR user, the URL is not valid. But for all the other users, so user 1 through 40, will not have this issue. So as a workaround, what I'm going to do is I'm going to restart that build process. And I'll show you what I'm going to change once I get it there. So what's going to end up happening is I'm going to change this, and I'm going to steal from user 1. So right in here, I'm going to change this to user 1. And whoever's user 1, thank you for letting me borrow your repo. Go ahead and start the build again. Okay. Okay.
So hey, while Jory's catching up his environment there, is there any questions? Does anybody anything any questions burning a hole in your pocket, so to speak, that you want to discuss while we're catching up the workshop a little bit?
No, it looks like a couple of folks had to drop off, Marshall, but we'll be following up with the workshop, following along at a later time. In the chat, of course, I replied to Dustin that we have the environment up for the week, but certainly available for questions, right? So are we planning on a hard stop at noon, or what's the, or I'm sorry, the different time zones? Are we planning on a hard stop in a half hour, or are we going to go beyond that some?
Yeah, so I think it's kind of dependent on everyone that's attending. I want to respect everybody's time, but we'll hang out and we'll keep working through the workshop for those that want to hang on for another hour or so. But yeah, definitely, we want to respect your time, and if you it's really up to each participant if they had a hard stop at the 3 hour mark, or if they were planning on staying for a little bit longer, or if they have time. to stay. So yeah, we can, but we'll, Jory and I will hang out and work through the rest of the workshop for those that want to stay.
So we'll continue for an hour and a half, and then we'll go ahead and end the workshop at that time, of course, but the environments themselves will still be active, and everyone's clusters will still be available to them, and they'll be able to continue their lessons. And then, of course, if they have questions, they can shoot them over to yourself or to Jory or to Scott Daniels. But I'll go ahead and send out that information so they know how to get a hold of us, or if they have questions on the workshop itself.
Fantastic.
All right, and going back on mute.
Okay, and perfect timing. We were able to get it working. It was that issue that we saw. Needed to use an actual user URL here, and that's how we were able to pull it down. So again, thank you everyone for your patience. But let's go ahead and continue. Let's go ahead and do OC get builds. So as you could tell, here's all the failed ones that I was working with a little bit ago. And here is it actually completing. So proof that we did fix the problem. And I'd just like to point out how convenient using the OpenShift console was to solving that issue. I did not have to go command line, and it was easy enough to go through and just click buttons to find where I needed to go. And just here's the build logs. So we were successfully able to get the image. And if we do a quick OC get pods, we have a brand new couple pods for this. And notice these aren't ready, so they're not running because they've already failed. So the build is completed as well, and here's the actual running service. And let's clear that and do it here. So here's the actual routes. So notice that we do have a national parks here. We do have two. This one's a remnant, which I can delete here in a little bit. And so now we should be able to go to the URL and see the page. Now for me, it should be that. Yeah. So right here, it's not much of a page. All it says is welcome to the National Parks Data Service. So the application does work. All right. And that is all we have for that one. So let's go ahead and move on. So now we're going to add on to the application we just made. We're actually going to add a database to it. So we're going to actually modify it with storage for the database and actually start up a database where it can pull things from. So, so when we create the MongoDB, there is a template out there with the OpenShift console, and we can literally just download it. It'll give us a base database with literally just bare bones database where you can start off with stuff. So let's go ahead and follow along here. We've gone ahead and we've created our template. We pulled it down and we put it into our namespace. And so we're going to actually deploy the actual database now. So back to the console. From the developer perspective, we'll click Add. And we're going to click Database. So we got plenty of options. And we're going to search for MongoDB. going to use MariaDB in this case. Normally it is not offered currently. MariaDB ephemeral job. So that is one gotcha in this lab. And just make sure to mark it to your namespace. If you have more like me, just make sure to grab your own. And we're going to leave it at 512 memory limit. And for the names, for the database service name, you can name it whatever default. You can do the MariaDB, or if you want to just follow along, it's okay to name it MongoDB-National Parks for the purpose of the labs, just to follow along if it makes it easier. I'm going to follow along as well with that. And version, we'll just go with default. So we will go ahead and create. Okay, so we are going to switch on over here to stay in the developer perspective and switch to secrets. And secrets we are looking for is search for national parks. So we're actually going to get the namespace and go down from there. So notice we have all the MongoDB and MariaDB here. All right, and so once we click the MongoDB National Parks secret, we can actually add a secret to the workload from there. But we had to drill down to your namespace, so your user number. And let's add the secret, and we'll go your national parks. And that is all we need there. And now let's see it start up. All right, we have one new pod restarted after making that change. And now we're going to go back to the MongoDB National Parks deployment. So sorry, from the administrator perspective, go down to workloads, deployments, and notice we have National Parks 1, or for me, but it'll be National Parks for everyone else. So we're just making sure we have the 3 labels here. So we have workshop, and we're missing a couple now. So we're going to add actually, no, we're good. We need to add one role actually. So we need to go ahead and add the role database, since this is now performing two jobs. Okay, so I already like the name of the exercise. It's called Exploring OpenShift Magic. So you got to know it's going to be good. So let's go ahead and follow along here. It wants us to get RS, which is getting the replica set. So this is just confirming, hey, we did have to restart something. So notice it's only been around for 100 seconds. It's pretty new. So all the changes we made did OpenShift felt the need, well, this is a big enough change, let's restart it. And now let's see if we can't get, so now apparently we can go to here and we can actually query for data. And that is mine. Your URL will work, mine is different. So notice, like, we tried to connect, but we also didn't feed it anything. This, we might be able to trigger it to load info. So hopefully what we'll see is we'll actually see it load information into that database. Connection issues. Okay, what this means is it's having trouble connecting to itself. Apologies, please bear with me. Okay, so instead of trying to troubleshoot the database issue for a long period of time, let's move on. So what would happen if the database was working for me is we would add some labels here and it would indicate some additional colors as far as I can tell. Now we would also then describe the route and see if it's exposed. And notice like we'll be checking for the labels. And okay. And if you check the browser, well, ideally what you'd see is you'd actually see plots on the graph, so you can actually see specific things. But for example, pizza looked like one of the labels was. Okay, so let's go ahead and continue on. We should be good without that database for now. Okay, so now we're going to actually look at the health. Before I start into that, is there any other questions so far? I know we've had a few technical issues that might have just helped confusion. Okay. So, so this is more around the application health. So this is what's actually going to help monitor your applications. So earlier, Marshall stated in his presentation that you can set it up to where if the application is not performing how you want it to, OpenShift will be smart enough to say, hey, let's just kill it and restart. So this is kind of what we're getting into here. So in over here. So we're going to go ahead and check the topology again. And we will click our national parks. On the sign panel, let's go ahead and click Actions. Here it is. And add health checks. Okay. So this is going to actually add a readiness probe. So basically, if this does not exist, it will fail. So we're going to use type will be okay. There we go. It'll be HTTP get, and we will use the headers and values. It will be blank, and the path will be ws/healths with a Z, because Z is just that cool. And it'll be port 8080. And we are going to go ahead and click create. We can just take a quick look at the defaults, but we are going to leave those as is. And in case you didn't notice that there was a little checkbox at the end of this readiness probe box. And we're actually going to repeat that for the liveness probe. And here's that checkbox. So we have 2 probes added. So basically, these are 2 monitoring things. So if it's not ready, it will fail on that file being missing, or for both at this point. So it does also provide the description here. So if we go ahead and click add, we've just added our first health check. And it is restarting. Oh. Was someone coming off mute to ask a question?
Oh no, sorry about that, Jory. I was off mute and I coughed, so
No worries.
didn't catch the mute button in time.
No worries. So we'll let this container come back up real quick, or sorry, the pod.
Yeah, and so just to expand upon what Jory said, these the readiness probe and the liveness probe, these are both ways that we can check the health of our applications. And so, as application developers, we can put in as sophisticated of a check as we need, but the each of those probes have a specific part of the have a specific part in determining if the pod is running correctly. And so when you're doing the liveness check, it's basically just connecting to that port, and as long as it can connect to that, then it's going to pass the liveness probe. And then the readiness probe is actually a way that you can perform some action within that pod. So it's the ability to actually check. The first check is to make sure that the pod is available, and then the second check is to make sure that the pod's actually able to do some work. And so so it's a couple of great checks that we can do. And when it fails those checks, OpenShift will automatically kill those pods and restart them, so that as we said in the lecture part, it automatically keeps our applications running properly the way that we design them to run. So so it's a powerful piece for especially for developers, that you can put those checks in there and make sure that your application will run and be stable.
Thanks, Marshall. So that being said, we're actually ready to move on. So now we're going to actually talk about like automating the build and deployment. OpenShift uses something called Tecton, and that will actually be the main tool that actually helps schedule these deployments and push them out across multiple platforms, whether they be VMs, containers, pods. And this actually was from Kubernetes. So this is OpenShift just utilizing Kubernetes native software. So let's show it off. So right here, let's do a quick clear. So you get cluster tasks. Well, we have a long list. So it's already got all these defined tasks in place. And notice they've been around for about 26 hours. And so now here's the two pipelines we created for national parks. Now for my screen, I have two. You should only have one. This was that from that issue earlier. This is the one we're focusing on here. Now let's look deeper at it. So what we're seeing here is the actual pipeline of how it's going to deploy. So here's the app name, where it's pulling its code from, and the fact that it is a Git repo, and the revision. So typically when we're building this, we're usually grabbing the latest. So when we deploy it, we can say, hey, only use this version, or we can mark it to latest, and latest will always try to pull the latest and greatest out there. And just the actual build. So it says what image we're using, a few settings right there. So this is for those days when you actually do make a major update to your applications and you want to deploy it across the board. So if you have multiple pods out there, let's just say 4 or 5, this will be the tool you use to actually push it out to all 4 of those pods. And it'll also be where you define how you're deploying it. So for example, if you want to just restart everything at the same time and like folks would feel it at the end, or they can do it rolling. So we'll do one pod at a time, wait till it comes up, and it will continue until it finishes all of those pods in that manner. So from the console view, Okay, so here under the developer perspective, we'll go ahead and click pipelines, and we will click our national parks that we just created. So notice it's kind of what we created earlier. So fetch repository, build, and then deploy. So this is purely high level of what these pipelines do. So that is what Tecton's doing at a high level. So moving on. Any questions so far? I know it's getting more complicated with this part. Okay. So let's go ahead and talk about adding storage. So for example, we always need storage for all of our applications typically, especially if we're hosting like a database. You will want the information to be retained but accessible from every pod. So let's show you how to add it to your pipeline. Okay, so we are going to go to administrator. Storage, persistent volume, claims, and we're going to add one. And this will be app source PVC. So for the size, we're going to just start with 1 gig. Now, this can vary between types of applications. Not every application needs hundreds and hundreds of gigs. Right owner, okay. And this is actually just setting the permission on that directory structure. And we will leave the rest and click create. So it is marked as created, so we can go ahead and switch back to developer. Back to pipelines, back to national parks. I'm going to honestly delete that to avoid confusion. And we're going to go ahead and click start. So we will be prompted to add the pipeline stuff. So basically, we're going to make sure everything is still as we want it. So note, I'm still borrowing user 1. And workspaces will be so the workspace will be PVC, and then here's the app source PVC. And what should happen is once we click start, this should start rolling out the latest application to any available pods. And you can look at this and watch how it works. And you do have this little loading bar down here. So if we wanted to, we can come up here and see that it's running as well. Click back in, same thing. We have moved from the fetching to the building. And the nice thing is we only had 1 task here, but this one will have 3. So as we hover over it, we'll be able to monitor each individual task, where it's at. And if you wanted to, we can even click this and look at the logs. So for the next step, here's the build logs. We can watch every little bit of it. So we're going to let it run its course. While it's doing that, we can look at kind of what we're going to be seeing next. So this is going to be triggers. So for example, this is where we tell it, hey, if we have some new code out there, actually automatically deploy it. So if you were to update GitHub or GitLab, whatever you choose to use, this should be where you can set saying, hey, if we get a new update there, if we see a new version, go ahead and update or kick off a pipeline update here. But I'm going to give this another minute here to hopefully finish up. And notice we just completed build. And the cool thing is we do have some cool statuses. So generate took about 2 minutes. The build took about now 3 minutes. And the actual push a few seconds ago was completed. All right, we will let this deploy. I think we can go ahead and start the next little bit in the meantime. And we'll check back in on that in just a moment or two. Okay, do a quick clear over here. So as I kind of mentioned already, the triggers are actually what's going to be listening. So again, if GitHub makes a change, so if we have a new update to GitHub, OpenShift will be able to keep an eye on it and say, hey, we detected an update. We're going to schedule a pipeline update, meaning deploy your updated applications. So more specific, I hate to read off it, but they do actually have it really well defined here. So trigger template is a template for newly created resources, and it supports parameters to create specific pipeline resources. So it's going to trigger the runs. The binding just validates it. So it's trying to ensure there's not going to be any false alarms with GitHub. And event listener, again, just as it says, it's listening for the events. But let's go ahead and give it a try. And what we're seeing here is very similar to the last issue I had to deal with, where it is checking my user profile in Git. So I'm going to borrow user ones again. Alrighty, so now we were able to pull all these files down and put them into templates for this namespace. All right, so with that, we are going to create a new pod. So let's go ahead and bring back up the console. And deploy is still finishing up, but I'm not too worried about it at the moment. So let's go ahead and go to topology. And to verify the new deployment, we should notice we got this new one at National Parks here. And EL for event listener has been created, so that's what that is. So let's go ahead and go into it. So actually we will go to, we're going to click it. And we're going to go to routes. So notice we do have a website. So if we want to go to it now, there's no guarantee it'll work, but we will try it real quick just to see. Notice that it's just an event listener. It's not necessarily going to provide us anything at this point. It's just listening for events. We're going to actually add to the code repository that we have on GOGS, so that one page we went to earlier, trying to track down the source of my issues. So I am currently sharing with user 1, so we will be mindful of what I change. Okay, so here's we're in. We did not need to put in an additional login. So for the settings, I do need to log in. So this will be your user number, and then the password will be GOGS, as it says here. This lab is lying. Okay, so we're going to see if we can do it without this one, without logging in. Okay, so you will not have this issue. It is just my account here. In an effort to not impede user 1's work, I'm going to sign out and use user 40 because it's available. There we go. Now we can at least see all of that. So back to the National Parks JS. And so what we're going to do is we're going to actually grab a webhook here. So here's the settings. And we're going to go to webhooks. We're going to actually add a webhook. And it will be GOGS. Okay, so we're going to paste our link, the link we had over here. No, not that one. It was. We're going to take this link. All right, so that URL came from the actual console here. In case you didn't notice, I'll go back over there. It was in the L National Parks topology for the routes. That's where we grabbed this URL here. And if we go back, it'll be application JSON, and we're only going to monitor for the push event. So meaning we will get, someone will push an update to GitHub, and it will be marked as active. So it's been added. Now, if we want, we can go to files, and we are going to look at the config.js in bin. Now, again, I am going to go ahead and use user 40 going forward, so I don't impede anyone else. And we're going to edit this with the little pencil button. And we're going to go to line 17 and change the display name. We're actually going to change this one. We're going to for me, it's line 18. If you are on the display name line, that is where you need to be. So the 17 here in the lab could be a typo. So just note the display name part of it. And we're going to rename it to Amazing National Parks. And then we are going to commit. And for committing, usually in a normal source controlled environment, you usually want to put something descriptive here. Updating display name. You can choose to add more if you want to. You do not need to. And I'm going to commit to the master branch. So now that it's been updated, what should start happening is we should be able to come back to the console and notice a change. So it started, and that is because it started and failed because I do have a different pipeline URL in the config. So if you're following along still, what should happen is you should get a succeed, but since I'm borrowing other people's folders, that is why we're having issues here. I can take the time and go ahead and fix that, but we did just go through the exercise. So far, is there any questions, comments, concerns so far? Because we have just completed all of it. So if we have no questions or anything, just want to say thank you for joining in the workshop, and also thank you for your patience on some of the technical issues we've had.
And it was a fantastic job, Jory. Thank you very much, and Marshall. And I'll go ahead and have Scott Daniels follow up with folks that joined the workshop. Make sure that they have a way, as I mentioned in the chat, but I'll have them send it out to the group. If they do have a question about the workshop during the next week or so, or questions on one of the exercises, they can send it to that, and then we'll get it to the right. We'll get it to the right person. So thank you very much, and thanks Prasad for sticking with us to the end. I know it's long. It's a long time to go through it, but hope you found the information very, very useful. Thanks. And with that, I'll go ahead and end the meeting unless there are any questions, comments. All right, everybody. Thank you.
Have a great weekend.
All right.